It's pretty wild, right? How, like, everyday tech, stuff we take for granted, suddenly becomes, like, essential when something big happens.
Oh yeah, totally. Like, think about the internet going down during a snowstorm.
Or even just, like, your phone battery dying when the power's out.
Yeah,
Whew, it's like, whoa, didn't realize how much I relied on that.
exactly. And that's kind of what we're diving into today, this idea of a tech that maybe we didn't think about too much before,
Right.
but then bam, global pandemic
And
hits.
suddenly everyone's talking about 3D printing. Like,
Yeah.
can it save us?
Okay, so full disclosure, it's not like 3D printing single-handedly solved the whole pandemic, but
But it did some pretty amazing things.
yeah,
And what we're going to unpack today is, like, how did it actually help?
yeah, what do they actually make?
And I think the really juicy question is, what does this tell us about the future? Even now that things are thankfully a bit calmer.
Right. So we're going to get into the nitty-gritty of it using a couple of really interesting studies.
One is a big review of, like, all these different 3D printing projects that popped up really early on, like right at the beginning of the pandemic.
And the other one gets really specific, looking at face shields and masks, like
Yeah.
the actual numbers on how long it took to print them, how much material they used, all that.
And it's important to note here, one of these studies really focused on that initial super intense period,
Yeah.
before April 1st, 2020.
Yeah, back when everything was just like so chaotic, so much uncertainty.
Like, do you remember those news reports? Hospitals running out of supplies, borders shutting down. It was crazy.
Total supply chain meltdown. And that's where 3D printing comes in, right? Because traditional manufacturing, those big factories, they just couldn't adapt fast enough.
But 3D printing, it's like way more nimble.
Agile, on demand. You've got a design, you've got a
Just-
printer, boom, you're making stuff.
And making it locally, too, which
Yeah.
is huge when all the global trade routes are jammed up.
Right, right. And another key thing, you don't need these massive, expensive molds or tools to make different things.
Just tweak the digital design and you're good to go,
And share that design instantly, anywhere in the world.
which is exactly what people started doing. Like, it's almost like before the official rules could even catch up.
Yeah, there was this like explosion of people just wanting to help. They had 3D printers, they saw the need, and they were like, let's go.
It was a real grassroots movement.
Absolutely. But of course, the FDA, they had to step in, right? I mean, you can't just have everyone making medical equipment willy-nilly.
Safety first, for sure.
Mm-hmm.
So they started issuing guidelines, trying to make sure things were effective and, not going to cause more harm than good.
And they teamed up with some pretty big players like the VA, the NIH, America Makes, basically trying to bring some order to the chaos.
It's fascinating, right? Like how this crisis forced everyone to kind of figure it out on the fly.
And it wasn't just the US. Similar things were happening in Australia with their TGA and in Canada. It was a global scramble.
So let's talk about what they were actually making. The first study we looked at, it analyzed 91 projects that were started, like right out of the gate before April 1st, 2020.
And the big takeaway was PPE, personal protective equipment. That was the main focus, like 60% of all the projects.
Which makes sense, right? Everyone was desperate for masks, shields, anything to protect themselves.
Yeah, and within that PPE category, one item stood out, face shields. They were like the star of the show.
62% of all the PPE projects. That's a lot of face shields.
But don't forget, they were also printing like ventilator parts. That was another 20% of the project.
Oh, right, because there were huge shortages of ventilators. That was a big worry.
Yeah, so that 20%, even though it's not the majority, it represents a potentially life-saving contribution.
And the other 20% was a mix of things, like swabs for those COVID tests.
And even like hands-free door openers. People were getting really creative.
Okay, so face shields, clearly a big deal. And when it came to the actual technology used, FFF, fused filament fabrication,
Yeah.
that was the most popular.
Which, if you're not a 3D printing nerd, just means the kind of printer you might have in your garage,
The kind that melts plastic and builds things up layer by layer.
Exactly. And it makes sense, right? Because those printers are relatively affordable, accessible.
And you can, like, whip up a prototype super fast.
Yeah.
It's perfect for a crisis where speed is key.
And that's where the whole maker movement really shined, It wasn't just the big companies with their fancy industrial printers.
It was everyday people, hobbyists, small businesses, all pitching in.
Which led to some really interesting situations. Like, did you know that they found 34 different face shield designs?
34.
34. all trying to solve the same problem, but with different approaches, different tweaks.
That's both amazing and kind of like overwhelming.
Right. Like, imagine you're a doctor and you're suddenly faced with all these different designs. Which one do you choose?
It's like choice overload.
But it also shows the incredible ingenuity, right? How many people were just like brainstorming solutions.
Some of them even came up with similar designs at the same time, independently.
Yeah, like the Prusa RC3 and the IC3D Budman face shields both appeared around March 16th.
It's like great minds think alike even when they're miles apart.
And then you had people modifying existing designs, like Nagami Design. They took the Prusa RC3 and adapted it for this massive robotic arm printer.
So, okay, let's talk timeline. When did all this 3D printing action actually start?
Well, the first documented responses were in February 2020, and both of them were in China.
Which makes sense, since that's where the outbreak began.
Yeah. One group, the Hunan Vanguard Group, they were making goggles for healthcare workers.
In another company, Winson, get this, they were 3D printing entire isolation houses for a hospital. Whoa, entire houses.
Entire houses. They'd been working on this construction tech before the pandemic, and they were like, hey, we can use this to help.
That's incredible. But the real surge in projects, it didn't happen until after the WHO declared COVID-19 a pandemic on March 11th.
Right. After that, it was like, boom, 92% of the documented projects started.
It's like everyone suddenly realized, okay, this is serious. We need to act now.
And initially, most of the activity was in Asia.
Again, makes sense given where things started.
But as the virus spread, the 3D printing response followed. It became a global effort.
And that's where the study points out a potential limitation.
Right.
They were mostly looking at English language sources.
So they might have missed some projects happening in other parts of the world, especially where English isn't as common.
Right. It's a good reminder that even the best research has its blind spots.
Absolutely. So we see this peak in project reporting around March 23rd, and then it starts to decline. Why do you think that happened?
Maybe because by then, some of the really effective designs had emerged, and people started focusing on those.
Yeah, there was less need to reinvent the wheel every time.
Plus, I bet the FDA guidelines starting to come out had something to do with it.
Oh, definitely. People probably hit pause, were like, okay, let's make sure we're doing this right, meeting the standards.
And some companies even started putting restrictions on who could download their designs.
Right, like in Vision Tech, they wanted people to register or sign waivers before getting access to some of their medical device designs. It was all about ensuring responsible use.
Makes sense. Okay, so we talked about the what and the when. Now let's get into the how. Specifically, how efficient were they at making these face shields and masks?
So the second study we looked at, they did this really deep dive into 37 face shield designs and 31 face mask designs.
All of them specifically for that FFF 3D printing tech.
Right, and what they found was really interesting. Face shields were way faster to print. On average, about half the time it took to print a mask.
And they used less material, too, about half as much filament.
And fewer parts. A typical face shield was like 1.5 parts, while masks were averaging 5 parts.
Which I guess makes sense. Face shields are basically just a headband and a clear sheet.
Right, while masks have to be more like contoured with different layers, sometimes filters.
So in a crisis situation where every minute counts, face shields seem like the clear winner.
Definitely. They even gave some specific examples. The fastest face shield they analyzed, MSD Robotics Lab V1, took just 46 minutes to print.
46 minutes. That's amazing.
And only 12 grams of filament. And they had a newer version that was still under an hour.
Wow. But then on the other end of the spectrum, the slowest face shield from IRE Corporation took over 4 hours.
4 hours and 34 minutes, to be exact. And it used 63 grams of filament.
So same basic function, but huge difference in efficiency.
It really shows how design choices matter.
Okay, what about the masks? What were the extremes there?
The fastest mask, the Collective Shield V0.354, took a little over 2 hours, 2 hours and 14 minutes.
And how much material?
32 grams, and it was a 3-part design. The interesting thing about it is it was printed flat and then folded into shape.
Oh, like origami.
Exactly. And because of that, it actually ended up having the widest footprint of all the masks they looked at. Yeah, really innovative. Now, the slowest mask was a whole other story. The Maker Mask Respirator V2, it took over 10 hours to print.
10 hours?
10 hours and 32 minutes. And it used a whopping 130 grams of filament.
Wow. Why so long?
It was a super complex design, 26 parts.
26 parts for one mask. That's wild.
It's like a 3D printing puzzle. But again, it highlights how design complexity impacts production time.
So it seems like in general, as designers revised their creations, the print times got longer.
Yeah, they were probably adding features, making them more comfortable, more effective.
But there were some exceptions, right?
Right, like the 3D Verkstand face shield and the Montana V2 face mask. Their print times stayed pretty consistent, even with updates.
And some designs even got faster.
Yeah, Tinkerine and Lapis P, they managed to reduce their print times in later versions. It's like they were streamlining the process.
And another interesting thing about the masks is a lot of them came in different sizes.
Yeah, about 36% of the designs offered multiple sizes. Unlike face shields, which were mostly one size fits all.
Which, again, makes sense. Masks have to fit snugly to be effective.
Right. And the bigger the mask, the longer the print time and the more material it used.
Like the Alex M mask. They had sizes from XS all the way to XL.
A mask for everyone.
Okay, so we've talked about time, material, complexity. What about actual cost?
Well, the researchers estimated the cost based on a standard price for PETG filament, which is a common material for 3D printing. They found that the 3D printed parts for a face shield could cost anywhere from 33 cents to just under $2.
That's pretty reasonable.
Yeah, especially compared to masks, which range from 96 cents to almost $4.
So again, face shields seem like the more economical choice, at least in terms of the printing itself.
Right, but it's important to remember this is just the cost of the filament. It doesn't include things like the clear plastic sheet for the shield.
Or the elastic bands for the masks, assembly time, sanitization, all that.
Exactly. There's a lot more to the process than just the 3D printing.
And it's not just about speed and cost either. Comfort matters too.
Oh, definitely. Another study by Wiseman and his colleagues, they found that a face shield that printed super fast was actually less comfortable to wear.
Ouch. So it's a trade-off, right? You might gain speed, but lose something else.
Exactly. And that's why user feedback is so crucial. A lot of those design revisions we talked about, they were probably driven by people actually using the PPE and saying, hey, this could be better.
Like the Tinkerine face shield, they added foam padding to make it more comfy and improve the seal.
And they eventually moved towards a design with fewer 3D printed parts, using foam as the main structure.
It's like they started with a very 3D printing-centric approach, but then realized, hey, other materials might work better for certain parts.
It's all about evolution, adaptation.
And the study also mentioned some limitations with the 3D printers themselves, like build volume, the maximum size of the object you can print.
Right. If you have a smaller printer, you're kind of stuck with smaller designs, even if a bigger one might be more efficient.
Like the Prusa RC1 face shield versus the Aeon 3D R1. One was tiny, the other was huge.
And same with the masked components. The A26 mask, one of its parts was tiny compared to the collective shield.
So it's not just about the design, it's also about the tools you have available.
Exactly. But overall, what this whole COVID-19 response showed us is 3D printing can be a powerful tool in a crisis.
It's like the ultimate example of distributed manufacturing. People all over the world using their skills and resources to help.
A global community of makers united by a common goal.
It's pretty inspiring, actually. So as we kind of zoom out from the pandemic, what are the big takeaways? Like, what does this all mean for the future?
Well, first of all, it showed us that 3D printing can really step up when traditional supply chains fail. It's like a backup plan for when things go wrong.
And specifically, face shields seem like a really promising application, at least with that FFF technology.
Right. They're fast, efficient, relatively inexpensive.
But even beyond the specific products, this whole experience was a massive learning opportunity.
Oh, absolutely. We learned a lot about what works, what doesn't, what needs more research.
Like, how do we validate the safety and effectiveness of 3D printed medical devices?
Yeah, and how do we create a system where those designs are readily available and approved for use in future crises?
It's like we need a 3D printing playbook for emergencies.
Exactly. And this whole experience has also got people thinking about more resilient, more localized manufacturing.
Like, maybe we don't want to rely so heavily on global supply chains all the time.
Right. Maybe having more local production capacity using tools like 3D printing could make us more adaptable, more prepared.
It's definitely making me think about the future of manufacturing. Like, could things be fundamentally different?
It's a big question, and I think the answer is it depends. Like, if we can move past the hype,
And really focus on developing 3D printed products that are viable, that meet all the safety standards.
Exactly. It's not just about the cool factor. It's about making things that actually work, that are reliable.
And that's where regulation comes in, right?
Yeah.
We need clear guidelines, frameworks to support this kind of localized manufacturing.
Absolutely. So to recap, 3D printing really showed its potential during the pandemic. It was fast, it was distributed, it filled a critical gap.